Good morning, student. As today in our next session, we are going to start with the last topic of the chapter, that is quality. As we know that sound is characterized, or it can be differentiated from one another on the basis of two factors that we have already studied. One was loudness, that was dependent on amplitude, and the second that we have discussed last time, that was pitch, that was dependent on frequency. Today is the last one, that is quality or temper. Okay, so what is this characteristic, or on what factors does it depend? Mainly, as we know that it is that characteristic which distinguish two sound if they have same pitch, same loudness. So how we are able to differentiate between them? Sound produced by any of the musical instrument or human being contain in small amplitude two or more waves having different frequencies, and those frequencies are integral multiple of frequency of their source. As we know that, since whatever we are saying, whatever we are calling a sound which is being emitted, each and every word has different frequency. As we are producing a tone. A tone is a combination of two or more notes. Okay, monotone, and when these tones will combine, they will become a note. So when we are producing a note, basically different frequency of sound is being emitted by us. So these waves are different in different sources. Due to the presence of these kind of vibrations, the waveform or quality of the sound changes. Waveform, as this is called the waveform. Like here we can plot time in seconds or distance in meter, and here is the displacement. Distance in meter or centimeter, and displacement also in centimeter along the y-axis. And each and every word, each and every device has different waveform. So it can be like this for some, okay, for some words it can be like this also. Okay, so these are the different kind of waveforms. So the waveforms, as these waveforms changes, because of that, the sound which is being produced, it also keeps on changing. The waveform is different for different sources, even if the loudness and pitch are same. So each vibrating body has its characteristic waveform. Each and every body has its characteristic waveform. And hence we are able to recognize or distinguish the vibrating body even without seeing them. For example, when we are telephonically having a conversation with the other person, we are able to recognize the voice of the person. How? It is because of the presence of this explicit function that is called quality or timbre. Because vibrations produced by the vocal cords of each and every individual person have a characteristic waveform, and that characteristic waveform is different from different person. Similarly, one can distinguish and recognize the sound which is produced by different musical instruments if even if they are of same pitch and same loudness. Now, as we know, this can be like this kind of waveform. It can be representing, suppose, a musical tone. Okay, so let us say a musical sound is getting produced by any musical instrument like guitar. So as its pitch keeps on changing, so if I will plot a graph, it can be represented by this. Okay, it is for suppose a guitar. And what about one more type of instrument that we have discussed last time, that is tuning fork. As tuning fork. Tuning fork has the tendency that it is able to produce a monotone. So this tuning fork which will produce a monotone. So that means if we will plot the graph, and it is a monotone, that means same amount of amplitude is produced by this kind of instrument. So it is like this. As you can see the difference in the waveform, so by this virtue we are able to distinguish between the sound which is produced by a guitar or which is produced by a tuning fork. So although we can say that their amplitude is same, amplitude means this value, let us say this value is 15, this value is also 15. So although this amplitude is 15, but say if amplitude is same, that means loudness is same, and frequency, number of vibrations which will be completed, let us say it is also ending up here. So the number of vibrations which is getting produced by these kind of waves, like for guitar, I am redrawing the figure. Okay. So ending up here. So almost the time period is same. So frequency is same, as as amplitude is also same, and frequency is also same. That means the two properties, amplitude describes loudness and frequency describes pitch. That means both these quantity, loudness and pitch, are same for the instruments. Like here I am saying guitar, here I am talking about tuning fork. But what is the difference? The difference is in the waveform. You can see this keeps on changing. Okay, so the waveform, it keeps on changing, it keeps on shaking. It can be of, sometime it is of high level, high tone, and sometime it is of low tone. So because of that, it is not smooth curve. Rather, the curve which is produced in a tuning fork, it is a smooth one which changes continuously. So a note played on a guitar or any of the musical instrument has large number of notes, while same type of note or same type of tone is produced by a tuning fork. That's why it is considered as a monotone or monotonic instrument. So uh, hence we are able to distinguish between the sound of a guitar and a tuning fork, or sound of various musical instrument which is being played up by uh, in a song or during any orchestra band, because they may have exactly the same loudness, same pitch, but their waveforms are different. So if in precise, we will discuss about the three qualities or three characteristics which were the main factor on the basis of which we can distinguish the sound. Those three characteristics are, first is loudness, the second one is pitch, and the third one is quality. So the main characteristics of sound. First one is loudness, which mainly depends on amplitude. Okay. The second one is pitch, which is dependent on frequency. And the third one is quality, which is dependent on waveform. Okay. So the next one is last topic, that is just like an activity that you can do, like making a musical toy. How we are able to produce a musical toy at home. For that, you have to take a shoebox, empty shoebox. Okay. So one by one, I am describing the steps. You can do that during these holidays also, which are going on. Okay. So what you have to do? Just listen carefully. How to make a musical toy. So for preparing a musical toy, you have to take, suppose you are making a guitar. For that, take a shoebox, the empty shoebox without any lid, and a cardboard cylinder that is just found in a foil paper. Foil paper are wrapped over that cardboard cylinder. So take that empty cardboard cylinder, and its diameter should be approximately 6 to 7 centimeter, and 5 or 6 rubber bands. We need it. Sellotape, scissor, and a pencil. Now, what you have to do, you have to take one end of the cardboard tube, that is the cylindrical tube, on one side of the shoebox, trace its outline. Okay, so after tracing the outline, you have to cut that circle part using scissor and make a hole on only one of the side. Now insert the end of the cardboard tube into that box, fold the edges of the tube inside the box so that it is clearly fixed, the cardboard is fixed, and then seal it with the sellotape. Stretch the rubber band across the shoebox, and what it will do, mainly when we will just put on 5 or 6 rubber bands, because of that the particular box will be compressed. If it is compressing the central part of the box, then play on the rubber strings with your fingers and you will hear a sound, twinkling sound, just like guitar. Okay, so this was just an activity which you can do at home. Only what you need, empty shoebox and cardboard cylinder, empty cardboard cylinder. After that, the various numericals, suppose numericals are there, solve exam, the numericals are given in your exercise. First one I'm talking about. So they are saying two waves of the same pitch have amplitude in the ratio of 1:3. What will be the ratio of their loudness and second pitch? As numericals. Okay. First one. What is given? Two waves are there. So firstly, it is being provided. They are having same pitch. Let us say the first one, amplitude of, I'm saying the first wave is A. It is given the ratio is 1:3. So 1 centimeter, or you can take it as X also, or X centimeter. or amplitude of B as 3 centimeter or 3x centimeter, whatever you may take. Okay, now what you have to calculate? Firstly, you have to calculate the loudness. Okay, loudness of A by loudness of B, their ratio. As loudness depends on amplitude, and when we have discussed the topic, we know that loudness is basically directly proportional to amplitude square, while pitch is directly proportional to frequency. So based on that, loudness of A is proportional to amplitude of A square, and loudness of B is amplitude of B square. Okay, that means it is equal to x square divided by 3x square. X square divided by 3 square, it is 9x square. X square get cancelled. So it is 1 is to 9. So the ratio becomes 1 is to 9. Loudness of A ratio loudness of B becomes 1 is to 9. Now what about pitch? As pitch depends on frequency, it does not have any influence by the amplitude. So we say that pitch remains same, and also in the question it is given same pitch. So what will be the ratio? It will be 1 is to 1. Okay, this is numerical number 1. Now let us start with the second numerical. Now let us start with the second numerical. The second numerical says two waves are having frequency 256 Hz and 512 Hz but same amplitude. Compare their loudness and pitch. Now in the second numerical already it is mentioned same amplitude. Okay, and their frequency are given. So frequency of A is 256 hertz and frequency of B, let us say it is given, it is 512 hertz. The first part that we have to calculate is loudness. And as loudness is directly proportional to amplitude square. So based on that same amplitude, that means loudness of A by loudness of B ratio is 1:1. This is the first part. Second part is pitch. Pitch of A upon pitch of B. As during the discussion we have already discussed that pitch depends on frequency. So it depends on frequency of A divided by frequency of B. So pitch of A by pitch of B is equal to 256 divided by 512. 1:2. So the ratio comes out to be 1:2. So pitch of A ratio pitch of B will be 1:2. These are the two numericals which have been provided in your book. Okay. Now the rest of the question answers from the chapter are already being uploaded on the website. Okay, the same website that in which the rest of the chapters have been described and the question answers have been provided. Now let us talk about one more thing, that is our holidays homework. What you have to do or what you have to complete in your holidays homework. And these are the three chapters which are part of the first semester portion in class 8 physics. So just complete your notes and question answers so that after this lockdown gets over, we are able to, and when we are able to resume our classes, you will submit your notebooks for the correction. Now, regarding the holidays homework, your holidays homework is you have to draw well labeled diagram of following. First one is change of state of matter. Second one is sublimation and deposition of ammonium chloride, and third one is density. The first two, you can find the given figure in chapter number 1. That was better. And this one is in physical quantity and measurement. Density bottle particular topic is given in chapter number 2. Now, where you have to draw these label diagram, you have to take a Milky file, and in those Milky file, you have to paste the plain pages and you have to draw the diagram. The diagram should be well labeled, as it has already been mentioned, well labeled diagram. And on a single sheet, you will draw a single diagram. Like for a single, for change of state of matter, you will use a single sheet. And the rest, the file should contain your name, class, name and class. Okay, in which class you are studying, and your name, full name. Okay, and your subject should be mentioned over there, which subject project you are preparing. Okay, so that's all for this first semester portion, and this was the topic for your holidays. Thanks.